All right, this is page 23. If you watched the last video, I accidentally said it was page 21 in the last video. I don't know, things happen. Can't go back and change it, so we're gonna live with that. So page 23, we are in notes 3. We're gonna start talking about the unit circle here. One of the things that it turns out is very important about the unit circle, or for the unit circle, is Pythagorean triples. And it's hard to understand why at first, but let's start by making sure that everybody knows these. And you should. These were in a previous video. I don't know which video, but at some point I said, these are the ones you should know. These are the ones you should know. Let's see. So 3 goes with 4, 5. 5 goes with 12, 13. 7 goes with 24, 25. 8, 15, 17. And then 20. This one's just my favorite. So I use it in a lot of problems. So it's useful for you to know it. I don't know if in general it's super important, but 20, 21, 29. That one's my favorite. So let's highlight it so that you be on the lookout for that one. It's the weirdest of the ones, right? Because it's the other 4 are by far the most common. That one just, you gotta have your personal favorites and things. So if you look at this picture, there's one thing that's like very obviously not right about it. And I don't even understand how it is possible. This is definitely not 1. I don't know why it was labeled that way or even how it was labeled that way. I think what happened was the program that I made, that I used to make this, I think that it didn't want this one that was here to be so close. So this one, I think it didn't want it to be this close to the edge. And so it took it and moved it down, but it moved it down into the dumbest place you could possibly move it. So this is definitely supposed to be 1 up here, right? And so this is the unit circle. So what is the equation of this circle? Well, it's centered at the origin. So it's like x minus 0 squared plus y minus 0 squared. So x squared plus y squared equals the radius squared, but the radius is just 1. So it's going to be 1. So it is called a unit circle because, so let's see, called the unit circle because the radius is 1. That's why it's a unit circle. It's not because like the area is 1, which I feel like would be a very good reason to call something a unit circle. Not the case. It's because the radius. So that's our equation. Now what's interesting is we can use the equation to find points on the circle. I mean, like that makes perfect sense, right? If x is 0, y is either 1 or negative 1. And if you look at your circle, so I don't know if I recommend that you do this, but there's a point here, there's a point here. If y is equal to 0, then x is 1 or negative 1. And if you look at your circle, there's a point here or here. Now those are fine and good, but those are quadrantals, right? That's where those have ended up. What we want to do is pick a point that's in the first quadrant, and it could be any point in the first quadrant. But we're only picking the x-coordinate, and then we're going to let the equation of the unit circle determine the y-coordinate, and then we'll have a point on the unit circle. So what I'm going to do is I'm going to choose to use, I think I'm going to use 3/5. So 3/5. So I'm going to let x be 3/5. So if x is 3/5, then 3/5 squared plus y squared has to equal 1, which means that 9 over 25 plus y squared has to equal 1. So y squared has to be 16 over 25. Now we're in the first quadrant. So even though we get a plus or minus here, so this will be plus or minus 4/5. Even though we got that, since we need to be in quadrant 1, therefore, the ordered pair we're going to use is 3/5, comma, 4/5. Okay, so that's what I'm going to use. You could actually, it wouldn't really matter what you choose. What I basically did was I took this Pythagorean triple and I divided through by the hypotenuse, 3/5, 4/5, 1. If I took this triple and divided through, I get 8/17, 15/17, 1. You could take any of them, right? Here, 20 over 29, 21 over 29, 1. So that's what I basically did. I basically took 3, 4, 5 and just divided by 5. And that's how I decided what I would use. The reason that works out really nicely is that you then get rational numbers for everything, right? We could have chosen x equals 1/2 or 1/3, but then you're gonna end up with a radical in it somewhere, and I didn't want to do that for this particular problem. So I'm gonna use this point. So what color should I highlight? I'm gonna use this point and plot it. So 3/5, 4/5. 3/5 is probably, let's say like here maybe? I don't really know. It's like 60% of the way there, whatever. And then if that's my point, then I got to go up to here because like once you know x, y is determined. So this ordered pair is going to be 3/5, 4/5. Okay, now what are we going to do with it? So what we're going to do with it is we're going to create a triangle. The triangle that we create is always going to be the same type of triangle. You're going to go from your point and you're going to go to the closest part of the x-axis. You're going to drop the altitude straight to the closest part of the x-axis. So let's do that. So we get that. All right, now I got to like try to move this a little bit so that it looks better for what we're doing. Yeah, I mean, I tried. That's the problem. Like I should have put the line segment and then put a point at the end of it. That would be the better thing to have done. But I didn't do that. Then what we're going to do is connect the point to the origin. So maybe use a marker or a pen, whatever you want to call this. We get this. Okay, so do you see the right angle? So there's a right angle here. In all of the types of triangles that you're going to draw, that right angle is always going to be at the x-axis. Always. The angle that we're interested in, because we're about to do some trig, the angle we're actually interested in this case, is between the terminal side, which is the hypotenuse, and the x-axis. So the angle we're interested in here, I think we're going to call this theta, is right there. Now, if you look at your triangle, you kind of see, well, you definitely see, hopefully, that, you know, we have this, and then we have this, right? And we know these. So these are, this distance right here is actually 3/5. This distance right here is actually 4/5. It's the x-coordinate and the y-coordinate. So the hypotenuse, we know, is definitely 1 because it's unit circle. So this is 1. So now we want to use this triangle. Why is there so much space here? Remember when someone says find 6 trig, blah, blah, blah. You organize your work. I don't know. I do not know why there's so much work, so much room there. There's a lot of room. So what I'm going to do is I'm going to use this triangle to figure out these values, right? So sine is opposite over hypotenuse. So that's 4/5 over 1. So sine is going to be 4/5. Cosine is going to be adjacent over hypotenuse. So that's going to be 3/5 over 1, which is just 3/5. And that's sort of interesting, maybe. Tangent is going to be opposite, so 4/5 over adjacent, which is 3/5. 4/5 over 3/5, because they're both over fifths. Tangent of theta equals, so it's 4/5 divided by 3/5. Because they're both over fifths, you can actually just like knock off the denominators and it's 4/3. But also look at that. It ended up the y-coordinate, right? The y-coordinate divided by the x-coordinate, which makes sense because you're doing opposite over adjacent. And opposite is y and adjacent is x. So this looks like maybe it's a thing. So this gives me 4/3, which I think is what I got. Yeah. Okay. Now the other ones you always just find by taking reciprocals. So I don't really go back to the triangle for these. What I do instead is just flip things over. Okay. Now, does anything here look familiar? So let me just copy this down here. The point used was 3/5, comma 4/5. Now look at your table, and do you see 4/5 4/5 and 3/5, 3/5. So if you look and see, it looks to me like for a point on the unit circle, so this is only necessarily true for a point on the unit circle. A point on the unit circle, let's say it's xy. X appears to be equal to the cosine of theta, and y appears to be equal to the sine of theta. Now, like the real question, sort of, if we had chosen a different point, right? So say up here, say you choose 7/25, and then as soon as you choose 7/25, you automatically get 24/25. If we had chosen that ordered pair, 7/25, comma 24/25, would the results have been different? Like, yeah, the sign would have been different. The cosine would have been different. But the sign still would have been opposite over hypotenuse. And for this picture, opposite is the y-coordinate. So it still would have been sine is equal to the y-coordinate, and cosine is adjacent over hypotenuse. Adjacent is just the x-coordinate, and the hypotenuse is 1. So we still would have gotten cosine is equal to the x-coordinate. So it doesn't actually matter what we choose. It looks like on the unit circle, cosine of the angle in question is just the x-coordinate of the ordered pair. And sine of the angle in question is just the y-coordinate. Now, the angle in question we got to talk about, right? So far, it's the angle between the terminal side and the positive x-axis. It's actually always going to be the angle between the terminal side and the positive x-axis. That's a thing we just have to agree on. But this is like a lot of information. So let me try to like summarize. This would not change if we picked a different point. So that's a really important idea. If we picked a different point, because, so let's see if we can say because, what does this even say? I mean, I tried to say because, but obviously it didn't come out. Because is a really weird word. It's like it has cause in it, like because, like, I don't know, like in the Bible, begat is like a word. Because opposite the angle is y, adjacent to the angle is x. So like sometimes you just want to write things, right? Like a sentence makes more sense here than like some mathematical garbage. So like do it. When it makes sense to write a sentence, write a sentence. And the hypotenuse so the hypotenuse, is that how you spell hypotenuse? I don't know. The hypotenuse is 1, which is the key feature of the unit circle. So this is key feature of the unit circle. Like there's a lot of circles, but the unit circle has a radius of 1, which is what makes all of these ratios simplify so nicely. Their denominators are all just going to be 1. So that's why your cosine is just going to be x over 1. Your sine is going to be y over 1. It works out perfectly because of the unit circle. So I think it'd be a good idea for you to try this again with another point. Maybe try it with something that's not going to be rational. Maybe try it with x equals 1/2. See what happens. X equals 1/2. What does y equal? What angle are you working with? If x is equal to 1/2, it means cosine is equal to 1/2. It means sine is equal to radical 3/2. It means that you're working with pi over 3. This is a big idea, right? Try radical 2/2. What angle are you working with? Try x equals radical 3/2. What angle are you working with? Think about those things. I will be back in the next video to do some more. So hope to see you there.